So now that we know about all of these different slopes and all of these different ways to write the equation, now we're going to go ahead and practice and do a really quick refresher on how to build equations of graphs. So we're going to write the equation of the line described. We want all of our final answers in general form. That's your ax plus by plus c equals 0. Okay, so we have a slope and we have a point. And almost always, this is what we're given. It's actually really nice that we're given a slope and a point as opposed to just 2 points, because now we can just immediately jump into our point-slope form, where you only need to have a point and a slope. My recommendation is to always write out your equation first. So y minus y1 equals m times x minus x1. Then I'm going to go ahead and plug in my values for where they need to go. 2/3 goes in for m. x1 is -2. Subtracting -2 is going to turn that into a plus. And then y minus 4. Since I want this in general form, I need to follow a certain type of manipulation, a certain type of algebraic process that gets it to be so that it's all set equal to 0 and so that there's no fractions. What I'm first going to do is I'm going to distribute that 2/3 into there. So I get y minus 4 equals 2/3 x plus 4/3. I'm then going to multiply everything by 3 to get rid of the fractions. I get 3y minus 12 equals 2x plus 4. And then I know that I want my a value to be positive, so I'm going to manipulate it to set it equal to 0 such that my 2 remains positive. If I subtracted 2x from both sides, it would become negative, which is fine as long as you multiply by -1 when you get to the end. But I'm lazy, and so I don't want to do that. I'm just going to keep it all to this side. So I'm going to subtract 3y from both sides. I'm going to add 12 to both sides. I get 2x minus 3y plus 16 is equal to 0. This is all a refresher. These are all things that you learned in 8th grade. So hopefully it's coming back to you. If not, I would recommend looking at your additional help and seeing what is out there for you to be able to practice doing this. Okay, x-intercept. We're given 2 points here, and we know that in order to write the equation of a line, we need to have a slope as well as a point. So our first step here when we aren't given a slope is find one. I go ahead and plug this into my formula for my slope. M equals, I'm going to do -3 minus 0 over 0 plus 8. And that is -3/8 for my slope. My slope is here. Now I have 2 points that I can choose from. It doesn't matter which point you choose it. It's going to end up being the exact same thing in the end. So what I would like for you to do is plug in the slope in either of those points and put it into general form. I would like for you to go ahead and it doesn't matter which one you put in, it'll all simplify down to the same thing. Go ahead and tell me what you get. Plugging in either of the points, I'm going to go ahead and choose my y-intercept. I'm going to do y plus 3 equals -3/8 times x minus 0. I'm going to distribute my -3/8. I'm going to multiply everything by 8. And then I'm going to manipulate this such that I get this x to be positive, which means I'm going to add 3x to both sides. And this is the answer you should have gotten. Whether you plugged in the y-intercept or whether you plugged in the x-intercept, it should be the exact same. You might get a multiple of this. Maybe you might get 6, 16, and 48, but I don't think so. I think it would end up becoming the exact same one. So just, yeah, there we go. Our last one is an undefined slope passing through this point. Remember that an undefined slope is a vertical slope. And we know that writing equations of vertical lines are always going to be, they're always going to be x equals a number. Why? Because no matter what is going on in a graph, your x value will always be the same. If you've got a vertical line, you're always at that x value, which means that that x value will always mean it, no matter what. Whether your y is 12, x is still going to be 5. Whether your y is negative a million, x is still going to be 5. So that's how we know it's x equals a number. Which number specifically, if we look at this point, it's the x value of that point. That's all you have to do when you write equations of undefined slope or a slope of 0. Because an undefined slope would be x equals 1. If we were talking about a slope of 0, a horizontal line, it would be y equals, and then you would take the y value too. So yeah, hopefully it's all coming back to you. Our last review on linear equations is just by graphing them. Your ruler is always crucial. Make sure that you have one and that you're using it. When we are graphing linear equations, it's just always really nice for it to be in a form where we can pick out a point and a slope. And the specific formula that we like to use, or form that we like to use, is mx plus b. Turning something into point slope form, that y minus y1 equals m times x minus x1, turning something into that form takes more, it's more difficult, and it's possible. It's just more difficult to turn it into that form than to turn it into this form. We almost never turn into point slope form. No, we never turn anything into point slope form. We always start with point slope form and end with something else. All that to say, we want to convert this into this form so it's easier to graph. So we have a point and then a slope, and then we can just put those points where we want it. So I'm going to isolate for y is pretty much everything that I'm doing here. So I'm going to add 4x both sides. Negative 8y equals 4x plus 24. I'm going to divide everything by negative 8. Y equals 4 over negative 8. Simplifies down to negative 1/2 minus 3. So I know that my slope is negative 1/2, and my y-intercept is negative 3. I'm going to go ahead and plot my y-intercept here at negative 3. A slope of negative 1 over positive 2, or we could do up 1, back 2. Doesn't matter, so you can go down 1, right 2, or you can go up 1, back 2. Rise over run. Either way, it gets you this line. Okay, why are we dealing with all of this? I'll tell you why we're dealing with all of this. We're dealing with all of this in regards to this problem right here, as well as piecewise functions. They're all going to be piecewise functions.